Welcome to Shrav's technical series. This is session 3 of Shrav's Boost Beast based WebSocket server. In part 1, we discussed of session 2, we discussed some of the changes we made to the code base. In part 2, we will continue the discussion. So please go through part 1 before going through this video. So in this video, we're going to discuss the 4 files we have skipped in the part 1, which is the publisher.cpp, shadestate.cpp, subscriber.cpp, and symbol.cpp. And before we discuss the file changes, let's go through the architecture changes that were made. So in this part, we added some more changes to the architecture. So for example, the mutexes. In the original example, we had a mutex at the shade state level. We added a mutex at the symbol level. So now each symbol will have a mutex. And then we added another queue so that the Redis subscriber will listen to that queue, single producer, single queue, and subscribe and unsubscribe from the Redis topics if there are no WebSockets listening to a topic. Say, for example, there's no connection request for Bitcoin USD. If you look at here, we can request for codes for either Bitcoin USD, Ethereum USD, or any other list of symbols. But if there's no WebSocket connection for a particular symbol, there's no point for the Redis subscriber to listen to that topic. So the Redis subscriber will listen to this queue, and based on which symbols there is a connection request for, the Redis subscriber will subscribe to those symbols. So that is the another change. And then back to the mutexes, we created a mutex at the symbol level so that when the WebSocket publisher publishes the codes at a very high frequency, for example, Bitcoin sends many codes at a very high frequency within a second, we don't want to block the whole mutex at the program level. So if it's a Bitcoin code, then the WebSocket publisher will only log the mutex for the Bitcoin symbol, and only those WebSockets which are interested in the Bitcoin symbol will receive the will receive the code for the Bitcoin. So this way we made the logs, the mutexes, more granular, and then that makes this multi-threaded application more concurrent. So now let's go to the Visual Studio Code and discuss the changes. So as I mentioned in the publisher.cpp, now instead of locking the mutex at the global scope, if you look here, initially we logged the mutex at the shade state level. Instead of that, we now log the mutex at the symbol level. So if it is a Bitcoin code that has to be sent, then we'll log the mutex at the Bitcoin symbol level so that the rest of the program can still continue. And then we get the sessions, which is the WebSockets that are interested in Bitcoin code, and then we'll send the codes to the code over the WebSocket. So this is all the original code. So that is the main change we made to this file. Now the shadestate.cpp. So the shadestate.cpp, once the program starts, we create a map of symbols, which is nothing but for each topic, we create a symbol class. So if this program is going to serve, say, Bitcoin USD, Ethereum USD, and any other topics, it is going to create a symbol object for each topic. So that is the instantiation we do in the init method. Then we create a global sessions set to which we add all the sessions, all the WebSocket shade pointers. Then we added these classes: WebSocket subscribe to symbol, WebSocket unsubscribe to symbols. So if you look at the messages we send, we can send either one, subscribe to these symbols, or to unsubscribe to these symbols. So those messages are handled by these two functions. Once, for example, say if I want to subscribe to Ethereum and Bitcoin symbols, first the program will create the list of topics that are all served by this program. So in this topics, we'll insert all the uh, symbols that are served by this program. So this is a set. So once we insert in the set, if it is there, it is not inserted. If it is not there, it will be inserted. So this is a set. So that's how we create a list of unique list or set of all the topics the program is managing. And then we also add the WebSocket. We log the mutex at the symbol level. And then if for this symbol, this is the first WebSocket that is requesting a connection, then we'll send a message on the single producer, single queue to the Redis subscriber so that the Redis subscriber can subscribe to that topic. And then we also add the WebSocket session shade pointer to the symbols set. So we create a set of all the sessions that are interested in that symbol. So when the publisher gets a message for that topic, say for example Bitcoin, the publisher will get the list of all the WebSockets that are interested in that code for Bitcoin, and then using this set, it will send the messages to all the WebSockets. So this is the reverse of the above function, so we can skip this. And then when the WebSocket disconnects, leaves the program, you have to remove the WebSocket from two sets. One is at the symbol level. So we have to go through all the symbols the WebSocket was connected to and remove that WebSocket from all those symbols set. And then we also have to remove the WebSocket from the global session. So that is the change. Then the parser we have discussed in the previous video. Based on the message we get, we parse the message and the topics, and we then subscribe the WebSocket to those topics. So that's the change for shadestate.cpp. Then we change the subscriber.cpp. This is the Redis subscriber. So as I mentioned in the architecture, the Redis subscriber will listen to this single producer, single consumer queue, and based on the message it receives, if it is a subscribe request to a particular topic, say for example Bitcoin, then the Redis subscriber will subscribe to the topic. If the program determines that there are no WebSockets subscribed to any particular topic, then there'll be an unsubscribe message. Then the Redis subscriber will unsubscribe from that topic because there's no WebSocket interested in that code. Then we create a counter here. We manage this counter plus, minus, minus. And if there is any topic to be any topic subscribed to, only then the consumer will consume. And we set the timer on this to 200 milliseconds. If there's no message, it will exit out. So that way, there are two logics here. So this cannot be long running, it has to exit out. So we put a 200 milliseconds timer so that it exits out, and then the thread will go to the message queue and gets a message from there. So this thing will run in a loop. So the thread will first try to consume. If there's nothing, then it will try to read from the queue. So that way it manages the state. So that's the subscriber.cpp. And then in symbols.cpp, we just added a set. So for example, this symbol, say for example, Ethereum USD, then it will have a list of all the WebSockets that are interested in Ethereum.usd by maintaining this set. So once the publisher gets a code for Ethereum USD, it will use this set to get all the WebSockets that are interested in Ethereum code, and it will send the messages to all these WebSockets. So with that, we conclude all, we have discussed all the changes we have made in the web server. So if you have any questions, please try to reach out, and thank you for watching.